Hey, what's up everyone? Today we're going to do a quick walkthrough of a pretty simple, straightforward stack overflow or stack-based buffer overflow walkthrough. The application that we're going to be targeting is called the ASX to MP3 converter. And essentially what we're going to do is we're going to take over the EIP and be able to insert shellcode into the buffer and allow us to execute our own code, which would be the shellcode. And in this case, we're actually going to pop a quick calculator and go from there. So let's go ahead and get started. So as you can see, I do have my IDE up here. I have a Unity debugger. It's the debugger that I'm familiar with and like to use. For those of you that are following along, you may be used to other ones such as WinDebug or things like that. But the process and the flow of how you exploit things is still the same. So I'm not going to sit here and talk a lot about the high-level overview stuff. We're just going to really just kind of like walk through it. If you want to find out more about the high-level overview of how stack-based buffer overflow works, I highly recommend you go out onto the internet and just Google it. You'll find a lot. There's quite a bit of use cases and just open research that's out there on the internet about this stuff. So we're really just going to walk through it. You'll notice that I am using a Windows XP machine. This is a machine that I was using when I was going through grad school for certain exercises when I was actually getting my degree in pen testing. So we're going to go ahead and start off. And basically what we have to do is we have to input malicious files into this MP3 converter. And so how we do that is we use this script called, I called it FuzzPy, or, Fuzz Python Fuzz, whatever you want to call it, right? And essentially what we're doing is we're having to hit the HTTP header right here, which we're loading into our variable called buffer, and then we're going to be fuzzing it with a bunch of A's, okay? But it's not going to launch it directly at this fella here. What we actually have to do is we have to create an M3U file, right? So that's why you have, we've declared F to open a new file called scary.m3u and write, all right? And then it's going to write what's in our buffer. And it's going to close it out, create it into a file. So let's go ahead and create that file. As you can see, we have the scary m3u file right here. So we're going to take that, put it in here. And as you can see, we have crashed the program. You see how it says pause down here. And then if we go up here into our registers, you can see how all these registers are looking kind of funny, right? We see the A's here. Okay, and we see the ECX has got some A's in it. That's the 41. Okay, the 41 is hex for A. And then we see that the EIP, that indication pointer where it's pointing things onto the stack, has been overloaded with A's. So that makes us know that we can actually take over the EIP by chance by at least sending it some amount of A's, right? Or sending it some amount of input. But we can't just send it, however much input we did. What do we do? 20,000 A's, right? That's a lot. So what we want to do is we want to actually find the exact amount that we need to send. So to do that, we actually need to create a special pattern of, in this case, 20,000 special bytes that we're then going to replace over here. And we're going to put in here and then redo what we just did. So to get that special array, I guess is the best way to put it, of characters, we need to do something called pattern create. And we can use that or do that using a tool that we integrate into Unity Debugger called Mona. So I've already put Mona into Unity Debugger. For those of you that are new to this, There's plenty of walkthroughs on the internet to do that. For those of you who have done this, you know what I'm talking about, right? You just put it into your Python commands in the immunity folder. So we're going to do pattern create, and we're going to do 20,000. Okay, so we got quite a bit. All right, and I've set my working folder to go into here, so I can just pull this up, take this pattern from the ASCII table right here, right? And I can put it in here. I'm going to press save. All right, and now we're going to delete that. And we're going to restart our program. All right, so we want it till it says running right here, and then our register window is cleared, okay? So now we have the application back up and running. And we're going to recreate that file. All right, there's scary. All right. And now we have this interesting looking thing right here. So this is where the EIP is pointing. So now we can take this and we can actually do something called pattern offset to find the exact amount of bytes that we need to hit the EIP. So we're going to do that, and we're just going to copy that address into there, and it should give us that we need 17,417 bytes. All right. So now we're going to do 17,417. Oops, just kidding. We need to do A times 17,417. And then we're going to add some B's to see if we can actually hit the EIP. So what we should see is that it should stop right here. This is the exact amount to hit the EIP. And then we should see B's go into, Alt-C. We should see this populate with 42s. That is the hex amount for the B. All right. Go back to this, and then just to make sure, just in case, it's always a good sanity check, just in case something happens, we do want to add some C's. And I always like to multiply that by the original amount that we sent. So we sent like 20,000, and then we subtract it from the length of the buffer. Otherwise, we're going to see a lot. All right, so same process. We restart the program. Okay, so now we should see it's up. And just for quality assurance, I'm going to take that out of there. All right. We recreate the file, throw it in there, and as you can see, we have a bunch of 42s there. So it looks like we're in the right track, right? So now we can say that we have actually taken over the EIP. So we're heading into the right direction. So that's good, right? So now what we need to do is we need to figure out like how we can actually jump what's called the stack pointer. So that way that we can actually start executing some kind of code, right? Again, if you want to learn more about how we jump the stack pointer, highly recommend you go and just look up some walkthroughs of going through other things. So, but in order for us to figure out where we need to jump, we need to do another command with Mono. We're going to do jump tech R for register ESP. And this is going to generate a file of a bunch of addresses that we need to use. And what it's going to do is it's going to generate this file and it's going to put it into our working folder here. So we'll see it here in just a minute. All right, and here we go. Now we got it there. We'll open this up and we have some jump ESP modules right here. So now what we're going to do is we're going to take one of these. We need to make sure that it doesn't have 0 at the beginning because that's a null byte and it looks like we're good. So we're just going to take this one and populate it to where we did have those Bs. Because then what it's going to say is it's going to say once it hits the EIP, it needs to make sure that it can jump the stack pointer, right? So the EIP is essentially becoming the jump ESP rule. So I'm going to put a comment here. Okay, so we need to make sure that we write this in little Indian, which is essentially backwards. All right, so it looks like we got that backwards, so that's good. So now what we're going to do is we're going to put in some test shell code. So we're going to put in what's called an int3. Okay, so where we have our C's, we're going to not replace them, but we're going to add something in between the jump ESP rule and that last buffer that we have. So we're going to do buffer plus equals, and we're going to do int3s, which is xcc, and we're going to do times 4. Okay. So now what we need to do is we need to essentially just do, again, what we've been doing. We're going to delete that, restart our program, press play a bunch of times. Looks like this is running, create our program, or I'm sorry, our file, throw it into here, and awesome, kind of. So as you can see, it doesn't look like we jumped anything, because notice how we're getting this exception handler here. So we shouldn't have gotten that. We should just be seeing int3 here. However, we're not seeing that. So what this makes us think is that, okay, maybe we calculated something wrong. However, after going through this exercise a couple times, I know that we didn't do anything wrong. So essentially what we need to do is add some padding between the int3s and the jump ESP address. So essentially it's just going to basically create a bunch of NOPs, which are essentially padding, right? That will allow us to go straight to where we need to go. So we're going to go back here and we're going to add some NOPs, okay. And we're going to do 90, okay. Times, we're going to do 60. If it's too much, we'll see. And so this go around, we should see a bunch of int3s here. Okay. So delete the file, recreate the file, throw it in there, and now we can see we have a bunch of int3s. Well, we got a couple. Let's see, we got 4. And then we got nops. Cool. So now we know that we're in the ballpark of where we need to go. So now what we need to do is, before we can actually finish up, is we need to do something called finding bad characters. Okay, so these bad characters are essentially things that can cause your buffer to become an issue. The technical term is truncated. So in this case, we're going to need to take out some of these bad characters so that we can actually execute our shellcode, right? So to do that, we're going to do Mona. Okay, we're still going to do Mona, but this time we're going to do a byte array. So we're going to do Mona byte array CPB. So for bad characters, X00, which is the null byte. So we're going to do that. It's going to create this list here. We're going to go into the byte array folder here, or file. Okay, we're going to create a new variable called bad char. Okay, so now that we have our bad chars, we need to actually place them somewhere else. So where we're going to place them is right after our shellcode. All right. And now we're essentially going to do the same process over that we just did. We're going to relaunch our program. Take it out. And we're going to carry the file over into here. Oh, we need to, probably be good if we created it, right? And as we can see, we've broke the program again. And if we go here, you can see how there's like this break right here. And you can see how this address, it's kind of, see how it's got these funny little characters, right? So we see all our nops, and then we see the C's, which are the int3s, and then we see how it breaks right here. So if we wanted to, an easy way to automate this is to do Mona compare tag F for folder or file. We're going to do copy this address. And then we're going to do byte array dot bin, because that's where everything is stored. Address, and it looks like it's 00DC604. And this is going to start giving us our bad chars. So it's always good to like kind of go through this a couple times just to make sure. So we would go in here and we would take out 09 and then do the process over again. Okay, so you have to keep kind of like rinsing and repeating and doing that, or sometimes it might give you all the bad chars all at once. However, I always recommend going through it a couple times just to make sure that you get everything. So now we're gonna go ahead and kind of like do a quick little skip over into the final section, because I don't want to sit here and walk through finding each and every bad char, and we're going to actually launch shellcode into the program and execute a calculator. All right, so we've completed our exploit here. So I went ahead and generated some shellcode. I did this over with MS Venom over in Kali Linux, and put this shellcode in here. So what this is going to do is it's going to essentially, hopefully, pop a calculator on the host system that we have here. And just to do a quick walkthrough rundown of what we're doing, we're setting the exact buffer amount that we need to hit the EIP. We're doing our jump ESP. We're putting some padding in there because we realized we could do that. And then after leaving the padding, we're going to execute our shellcode. And then actually I need to change that to shellcode just in case. And yeah, and then this is essentially just like what's left over just in case it doesn't work. So I believe I've already created the file. I did, but you know, let's just for sanity's sake, let's delete that. Let's go ahead and run it again. We're gonna put this program in, and as you can see, we've popped a calculator. So that wraps it up for this video. As you can see, we successfully exploited the ASX to MP3 converter by doing a basic, straightforward, stack-based buffer overflow.